Yes, I can see your screen.
Um, Hello?
Yes.
So, I had given one previously. Did you try it?
Okay. Sorry?
Yeah, the code which I have given you previously, did you tried it?
Key means? Yes.
Yeah, yeah. So have you got any doubts?
No,
Do you
no.
need any
You
explanation of this code?
no. You can keep going to the lesson.
Okay. Hello?
Yes.
Yeah. So uh, clustering problem, like I mean, what kind of a problem we can use clustering? So how do I group documents by topic? So for that, we use clustering. And like, how do I group my customers by the purchasing pattern? For that, we use clustering. And sort the items into a group by similarity. For that, we use clustering. So I was about to explain the iris data, right?
Yeah.
Hello.
Yes. Yes.
So yeah, here is the for iris data. Just want to show you.
Yes. Yes. I know Irish data.
Okay. So this is basically a iris data. This data is already there. So I'm making the target variable, that is species, because I have to deal with the numeric data with in k-means clustering. For that, I'm making the species as a target variable.
Okay.
So there are three species, that is Setosa, versicolor, and virginica.
Okay.
So I'm assigning iris data to a new iris where I'm removing the species. That is like new iris dollar species is set to null. So
Okay.
if you check new iris right now, so you're not finding any species over here. You have only few columns, that is like sepal length, sepal width, petal length, and petal width. So now you don't know which has to be assigned to which cluster, which group you have to assign.
Okay.
Hello.
Yes. Yes.
So for that reason, like, yeah, you are applying k-means clustering with the cluster number as 3.
Okay.
So you have assigned into 3 clusters, and you are keeping that in a table, and you are labeling it. You have 3 labels, like you can give any labels, like, but I'm taking iris dollar species, that is versicolor, virginica, and one more is setosa. You can give any
Okay.
other name, not an issue.
Okay.
you are assigning, you are like using a k-means clustering, you are assigning the clusters. I mean, like you are assigning the values to the clusters based on their distance. So k-means basically uses a distance measure, that is a Euclidean distance measure.
Okay.
Suppose I would like to calculate the distance between 6.7 and 6.3. If I get the value, like suppose 1 or 0 or something 0.33 like that, and again like 6 point, I'll calculate the measure distance measure between 6.5 and 5.9. So again, if I get the value like 0.33, I'll consider these two are similar and assign it to a cluster. So similarly, if I get more difference, I'll assign it to the different cluster.
Okay. What do you mean for clustering vector? The output. Choo.
What?
The output of clustering. Scroll down. Means clustering. Clustering means clustering vector. The top the no, scroll down to the console. Scroll down to console.
Yeah, this one.
No, console.
Table.
The
Then yeah, here. Okay.
yeah, you have yes, clustering vector. What do you mean?
Yeah. So it's a clustering factor is nothing but the result which you have you know you have assigned 3 clusters, right? So you have taken the
Yes.
value here 3.
Okay.
So that is stored in a factor.
Yeah.
Table of factor is 3. Factor is 3.
Okay.
So k means that inside it calculates the distance between the data points,
Yeah.
and whatever the result that you get out of that distance measure, right?
Yeah.
So when you are calculating the distance between different data points, you will get different results.
Okay.
The results which are similar are assigned to one cluster.
Okay. Okay. Okay, please keep going.
So yeah. So I have taken a sepal length and sepal width, and this is how the cluster goes. Based on the sepal length and sepal width, I just want to cluster. I want a cluster of a species.
Okay.
A species which has a sepal length, similar sepal length and sepal width are clustered into 3 groups.
Okay.
So these are the centroids. Have you come
Okay.
across what is centroids?
Yes.
Yeah, I
Yeah.
mean like centroid is a one which is closer to all the elements in the cluster, all the data points in the cluster.
Okay.
So
How can I
basically,
evaluate?
what?
Do you know how can I evaluate the overlapping between centroid black, I think, and green? The overlapping.
I didn't get you.
The cluster is not
Yeah.
divide. There are some data that overlapping between 2 clusters. How can I value this overlapping between centroid green and centroid black? I think this color.
Yeah.
How
Centroid
can you
is
understand this overlapping between 2 centroid 2 cluster? The red one is perfect. All the data are near to the centroid, but the green one and the black one is like a little bit different.
Yeah. So the centroid is the one which contains the average value of all the cluster,
Yeah,
all the elements in a cluster.
yeah, yes, but some data of centroid green
Yeah.
going
Yeah.
to the centroid black.
No, no. Whatever the points, this is like completely distributed and have specified with the different colors. I mean, all these what you are seeing, red, green, and black in color, those are all the data points. So my job is to identify the centroid and nearby the data elements which are similar.
For your opinion,
Hello?
yes, for your opinion, how can I explain these three centroid and some overlapping between data? So, for example, I want to. Sorry.
Yeah, yeah. Please continue.
Yes, sorry. For previously you spoke about document topics. So maybe this dataset is for document topics. When you go into your customer, okay, you have three centroid, three clustering, which three different topic, but between two there are some data overlapping. Okay, what do you think? Well, how can I explain this overlapping? Maybe two topics is more close, and once is totally different.
The variance between these two are very less. So that's why like you can see the overlapping.
Okay. Yeah, because I'm wondering. Sorry, please continue.
Yeah. Please continue.
Yeah, I'm wondering maybe if I don't know the data, because in this moment we know the data, we know Irish. Maybe I don't know very well this data. Maybe document topics for my client. It's the first time that I see this document. Maybe I thinking, okay, I got the overlapping between the two centroid. Maybe I can set up my key means with 4 centroid. Maybe I don't know is the right way or is wrong way to approach this problem.
You want to document the
Set
topics,
up
right?
no. Okay, it's Irish dataset. If I see this data, maybe I think there are overlapping between two centroid. Maybe I'm wondering I can set up my key means with 4 centroid. Maybe.
Okay.
I don't know if the right way to approach this problem, but if I see the centroid red, green, and black, between green and black, I see overlapping data. So maybe, okay, I try to set up 4 centroid.
Yeah.
Yes. So let me.
Yeah.
Yes, please. Tell me.
Yeah, please continue.
No, I'm finished. I'm just wondering to use this technique with my, I don't know, my future client. So I just wondering if I see this kind of problem, how can I approach to solve it? Yes, I'm finished. Let me your opinion.
One centroid is overlapping on the another if you are not able to cluster it properly.
Okay.
Hello? At that point of
Yes.
time, you can either increase the number of cluster for more clarity, or you can suppose if you are sparsely finding the data points around cluster. Suppose there is a centroid and around which only 2 data points are there, and such millions of clusters are there which have only few data points around it. At that point of time, you can decrease the value of a cluster. For that reason, we do not want to take a risk, so we want to go with the WSS, that is within sum of square method, to find how many clusters we will be needing it. Because this is a very small data, and for that we are using anyhow, like I mean, even if you take 4 clusters, it doesn't make a much difference. So
Okay.
when there is million data points at that point of time, like we go for this optimization, like optimal value of k. So we
Okay.
go for this.
Okay. But
So I'm
if
grouping for the
you
same thing, like k means clustering.
yes, but if you don't know
Yeah.
very well, you don't understand very well the data, how can I set up the centroid? How can I set up the centroid? You put a number without any sense?
Initially, yeah.
Yes, yes. Please answer. Because I'm
No,
thinking,
no.
okay,
Initially, when you apply the k mean, yeah, k means clustering.
yeah,
Yeah.
yes,
Then when you are using the k means clustering, it randomly assigns one data point as a centroid. So I mean, it also calculates the difference between the different, whatever the results that you are getting from the distance measure, right? So if it is more than that centroid which you have like assumed randomly, so that will be a centroid for the next iteration.
okay,
Hello.
yes, yes,
So initially it takes the k means takes a random point as a centroid.
okay. Please keep
Did
going.
I clear your point? I mean, do you have anything?
No, no,
Yeah.
I'm
So with
literally
this iris data,
understanding. Please keep going.
you're not understanding.
No, no, I'm understanding.
Okay. So this is the optimization technique within sum of squares.
Okay.
So here, this is for iris data. Similarly, the data which I have given you, like customer data. So you can calculate the within sum of squares in order to um, identify how many clusters you have to use for your data.
Ah, okay.
So are you able to see this elbow point?
Sorry?
This elbow? This is,
No,
are you able to see this elbow?
no, no.
Like, I mean, in a graph.
Ah, yes.
I
Okay.
mean, yeah.
Yes, yes.
So if you're in a confusion that, I mean, how many clusters I have to take, so at that point of time, like you can see this, you can use this WSS method, and this gives you a clarity that how many clusters you have to use. So that is, are you able to see this elbow point? The first elbow point is considered to be like, it is considered to assign the number of clusters. So in this point, so it is in between 0 and 5, and the value may be 3.
Okay.
Hello.
Yes, yes.
So within 0 and 5 you can take any values, but the optimal value will be 3. If you plot a small points over here, so you'll be coming to know like the value varies between 2 and 3 or 3 and 4, and not exactly 5, because you are not able to see one more elbow here, and first elbow is considered uh, is given a priority.
Okay.
So similarly with this
Yes, yes. I understand.
data set,
Please keep going. I'm taking notes.
uh, yeah. So there is a quantity, invoice date, and unit price, and customer ID, and the country. So what are the insights you can get from this data? So one, The very first thing is you have to slice and dice the data in order to, like why we are using k-means clustering for this. So this is the basic question. So we want to understand the customer behavior and group them.
Okay.
Hello?
Yes, yes.
So we want to group them, and we want to group them because we want to like achieve some business values after grouping them. So that suppose if we are able to group the customers based on their purchasing behavior, if some new products comes in, so if we know who are all interested in such products, so we can actually send them mails, or we can send them,
Yes, you can send it.
yeah, we can do the, yeah, we can send a mail campaign, and we can promote our product by sending SMS to those customers.
Okay.
So for that, you need to understand the historical data. I mean, like, understand the historical data in order to group the customers. And if you are if you are able to understand the behavior of the customers with the previous data, you can predict that these customers are going to buy a product or not. I mean, if I suppose introduce a new product, how many customers are going to buy this product? So such a insights can be like used for a business value.
Okay.
So this is the data, and so initially what you are doing here is you are taking a small part of a data. You're subsetting the data based on the invoice date.
Okay.
And in order to, you have to calculate, for calculating the returns. For the return, hello?
Yes.
Yeah. So you are going to calculate the returns. I mean, few customers, they purchase the product and they do not return. So few customers, they purchase the product and they'll return immediately all the times. There are few customers who purchase the product and they'll return the things, uh, like, I mean, sometimes they'll return back and not always.
Okay.
So with this data, initially you want to like, we want to, um, what do I say? We want to find the customers who have returned the product.
Okay.
Hello? Yeah.
Yes, yes.
So since we are going to cluster in future, we do not want, yeah, we do not want anything to be in as a character data. So we want everything as a numeric data.
Okay.
So I consider 0 as the number of customer who have returned the product, and 1 as the number of customer who have not returned the product.
Okay.
And the data contains different missing values, which you can call it as the outliers. So we have to remove that, and for that I've used a function na dot remove.
Okay.
So, and here you are grouping the customers. Can you see these customers?
Can I see the customer?
Hello?
Yes. Could you repeat the question?
Yeah. Um, the customers, basically you are grouping the customers by their customer ID
Okay.
here in this code.
Which
And the
line?
next thing is like this one.
Okay, customer ID. Yes, yes.
Hello?
Yes, yes, customer ID. Okay.
So you are identifying the unique, yeah, you are identifying the unique customers and you are grouping them based on, I mean, you are sorting them based on their customer ID.
Okay. What do
The
you mean
second behavior
for?
is you want to identify, so how recently, yeah, please continue.
Yes, what do you mean for true 0 and 1? Data, purchase invoice, if else data,
So
0 and
yeah,
1.
so if the customer is, yeah, if the customer has returned the product,
Yeah.
then I'll consider it as a value 0.
Okay. Yeah.
If the customer has not returned the product, I'll consider those customers with the value 1.
Okay. Okay.
Next thing is how recently, I just want to observe how recently the customers have purchased or returned the product. So for that, I have to assume one particular, I have to consider one parameter, like in which date he has purchased the product, and like whether he has returned the product and whether he has not returned the product, that will be calculated by this one, returns.
Okay.
And I just want to know how recently he is like purchasing the product.
Okay.
So I have considered 2011, 12, and 10th 10th of December of 2011 to the date, invoice date.
Okay.
So how many purchases he has done, and at the same time, like how many returns he has done and how many non-returns he has done.
Okay. Please keep going.
So this is how the recent transaction is calculated.
Okay.
And I just want to also know how frequently he has made a transactions, how frequently he has done a transactions.
Okay.
So this is how I'm slicing the data here. So here I'm considering the customer ID, invoice number, and purchase invoice. So I'll get a frequency that how many times he has done a transaction.
Yes, please keep going. Hello? Hello?
Yeah.
Ah, okay. I can hear you.
Hello?
Yes, please keep going.
Yeah. Out of it, I'm considering he has only, I'm considering the customers who has done only purchases and have not returned back. And I want the
Okay.
frequency of those customers.
Okay.
So once you're done with it,
Hello?
yeah, once you're done with it, the next thing is like, hello,
Yes, yes. I can hear you. Please keep going.
yeah, yeah. So you have to consider how much profit you are getting, the total spent time in each item of
Okay.
those customers.
Okay.
So that is calculated by this formula, which you are seeing, this one.
Okay.
So this is the unit price
Yeah.
that is multiplied with, 1 second. So that is multiplied with the quantity, data quantity.
Okay.
So next comes like 80 by 20 rule. So I have identified the customers who have only purchased and have not returned. And on the other way, I have identified the customers who have returned as well as purchased, and the customers who have done only return.
Okay.
So the customers who have only returned and not purchased at any point of a time, every time he is going to return the product after purchasing. So those customers are not at all good for our need. So I'll consider them as outliers.
Okay.
So this 80 by 20 rule says that out of 80% data, I mean like 80% of the data is because of the cause of 20% transactions.
Okay.
Hello?
Yes, yes.
80% of the transactions will, yeah, 80% of the transaction will happen because of 20% of the transaction. 80% of the effect will happen because of for 20% transaction.
Okay. Hello?
Yeah.
Hello? Yeah.
So, yeah, hello. Yeah.
Yes, yes.
So this is how you apply the 80 bar 20 rule.
Okay.
So do you have any doubt in this?
Maybe
So here you
if
are calculating the cumulative sum. Yeah.
yeah, maybe if I see the code running, should be better because it's very long.
Okay.
Maybe step by step,
Okay.
you can explain me and show me the output because it's very long code.
Okay. Uh, is it
Yeah,
is
yeah,
it
yes.
okay if I show tomorrow?
Yes, yes. You can keep going to explain the code. Maybe tomorrow, step by step, you can explain and show me. Explain and show me because I understand, but in general, no. In specific part, maybe
Okay.
I. Yes, please keep going.
Okay. Yeah, this is how we calculate. 80% is I'm labeling. I'm just labeling because this is like 20% as a top and 80% as a bottom. This is just a label. You can give anything over here.
Okay.
So here I'm going to reduce the entire 20% of the data, entire data into 80 bar 20.
Okay.
So I'm going to keep that in a factor that contains basically two levels. One is 20% out of the data, and the rest is 80% of the data.
Okay.
So now if I consider only the 20% of the data and start doing analysis, so there will be like lots of variation between the data points.
Okay.
Suppose if I consider this thing 17850 and suppose 13047. So if I reduce this value and if I calculate variation, so there will be lots of variation, right?
Yeah.
So if I want to bring that to a one scale, so for that I'm using log. Log basically reduces the huge value and brings it on a scale.
Okay.
So Z score is basically the scale function. What you're seeing is right that standardizes the value. So in
Okay.
this part, you are reducing the huge value, huge data point, because there will be millions of data points. So you cannot consider the data point as a whole. So for that, you have to like take a small value of it, and it should not affect the attribute of a data point.
Okay.
So this part basically reduces a huge data point into smaller values, and this point, this Z score, what you are seeing, right?
Hello?
Yeah, this Z score brings all the data points into one scale so
Okay.
that you can measure it. So the next part is handling the outliers. So outliers is nothing but, as I have told you, the customers who has not done any transaction. Like I mean, they have just purchased and they have not returned. I mean, they have not at all purchased and they have only returned. They doesn't, what do you say? Uh, they won't be like profiting us in terms of money.
Yes. Yes.
So I have to remove those people. So this is what this code explain.
Okay.
This delete. So if you are having what missing values and improper data, improper values, at that point of time, that is also considered as the outliers.
Okay.
Anything which is out of your assumption, out of your hypothesis, is considered as the outliers. The outliers has to go with the different dimensions, because in different cases they'll consider different things as outliers.
Okay.
So the next point is, as I told you, I now I want to cluster these data points. I've reduced the huge data points to a smaller points and have brought it into a scale. Now I can measure, and I have enough numeric value with me. So now I can use a k-means clustering.
Okay.
So now a question raises like, yeah, now the question raises like how many data points I should use. So for that, this is the one. So so this NB class library that in turn uses a within sum of square method to calculate, which I have shown you, right? Elbow graph.
Okay.
Yeah, I mean, like you will calculate the within sum of squares, and you will come to know like how many data points you are going to choose.
Okay.
So once you get how many data points you are, I mean, how many clusters you are going to choose. So you
Yeah.
will apply, I mean, you will mention the number of clusters as 3 or 4. It depends on the graph that you will be getting.
Yeah.
And later you will apply the k-means clustering to cluster it.
Okay.
So if the centroids, once you apply the k-means clustering, if the centroids are overlapping or tightly packed, and you are not able to see which cluster which is differentiate between the two clusters, they are tightly packed with each other. At that point of time, you can use more number of clusters. Like suppose if you are using 4 clusters now, so at that point of time, if such scenario arises, you have to use 5 or 6 clusters and repeat the process.
Okay.
So are you aware of how the k-means clustering works inside?
Yeah. Yes. Yeah, I need to thinking about. It's a lot thing.
Yeah.
Yeah, it's a lot concept that I need to understand. Maybe I understand, but
Which one?
no. If I see the code running, maybe I think I understand the key means. Should be better see the code running. Maybe tomorrow. Don't worry.
Yeah, surely, surely.
Are you finished?
Yeah, yeah, yeah. One
Okay.
second. So, yeah, one second now. Yeah. So this graph you have not understood. You are not, I mean, like, got a clarity about this, right? Previously.
Yes, yes. Could you send me this slide and the code, please?
Yeah.
Yeah, could you send me
This
this
one, this
slide?
slide.
Yes, could you send me for email this slide and the code?
Yeah.
Maybe I will check.
Yeah, sure.
Thank you.
So this is the reason why we choose k-means clustering, and why when we should not use the k-means clustering. So k-means clustering is basically easy to implement when you consider some other clustering methods. So when you do not have very much, hierarchy for clustering, at that point of time, you can use k-means clustering. You just have to name uh, the objects, and you just want to like group the object based on the similarity, where there is nothing much complication. At that point of time, you can use k-means clustering. If you have lots of categories within the cluster, at that point of time, you can use a hierarchical clustering, which I'll be telling tomorrow.
Okay.
So and k-means clustering, it works only with the numeric data and nothing else. if you have a categorical data, then there is one more method that is recently they are using, that is k-mode method, that works with both categorical data as well as the numeric data. But purely k-means clustering, it doesn't deal with the it doesn't deal with the categorical data, it only deals with the numeric data.
Okay.
So I told you, like, I mean, the scale function I'm using for standardizing. I mean, I just want to bring the numerical variables into a one scale so that I can measure, right?
Yeah.
So if you do not have a proper, one second, hello, hello, ಹಾ ಹೇಳು. ನಾನು ರೂಮಲ್ಲಿದ್ದೀನಿ ಕಣೆ. ಇಲ್ಲ ಆಗಬೇಕು. 9:45 ಹಂಗೆ ಮಾಡ್ತೀನಿ. Hello.
Yes.
Yeah, if you do not standardize the data, then it is not possible to apply the k-means clustering. That's what this point say about. And yeah, I mean, like, since you have a measure like within sum of square method, so yeah, you can assign the clusters. If you do not calculate it, how many clusters you are going to use within sum of square method, you may end up with some bad clusters.
Okay.
So guessing won't be work all the time.
Okay.
So that's what, like, I mean, for a complicated data, we are not using k-means clustering. We'll use some other methods.
Okay.
Yeah, uh, that's it for the day. If you have any queries, you can ask me.
Okay. Yeah. Maybe I I'm study the slide when you sent me, and we will I will talk about tomorrow.
Oh yeah, sure.
Thank you, Sankita. See
Thank you,
you
Venkat.
tomorrow.
Sure, sure. Thank you.
Have a good day and have a good night.
Thank you so much.
Bye.
Have a good day. Bye. ಹಲೋ. ಹಾ, ಏನಕ್ಕೆ ಕಾಲ್ ಮಾಡಿದ್ದು? ಹೊರಗಡೆ ಹೋಗ್ತಿದ್ಯಾ? ಓಕೆ. ಅದೇ ನಾನು ಏನಾದ್ರು ಹೊರಗಡೆ ಹೋಗ್ತಿದ್ಯಾನೋ ಅನ್ಕೊಂಡೆ.